Every digital image you see is just a massive collection of tiny colored squares. Let us look closer. If we zoom into a single patch of this face, we find a grid of pixels. Typically, JPEG handles these in small, manageable 8x8 blocks. To a computer, these are not colors, they are numbers. For grayscale, each pixel is a brightness value from 0 to 255. In this block, you can see the values drop from 200 to 50, marking a sharp edge where light meets shadow.
Wait, if we have to store 64 separate numbers for every tiny block, isn't that incredibly inefficient?
Exactly. Storing 64 raw integers for every tiny fragment is why uncompressed images are huge. To save space, we need a smarter way to describe these patterns than just listing every single value one by one. Instead of raw pixels, we rewrite the block using these 64 basis functions. These are fixed patterns of increasing complexity. Think of them as the building blocks of every possible 8x8 image. We treat our image as a recipe. Every block is a weighted sum of these patterns. By finding the right weight or coefficient for each basis function, we can perfectly reconstruct the original pixels. We call these weights f of u, v.
So we're just translating the same information into a different language?
The Discrete Cosine Transform formula calculates these weights. It compares the image block to each pattern. If a pattern matches the image's texture, its coefficient is large. If not, it's near 0.
But why use these wavy cosine patterns instead of just smaller squares?
Take a smooth gradient. It is mostly flat with a slow change. In the DCT world, this is simple. It only needs the top left low-frequency patterns. The high-frequency details, they are all 0 because there's no noise or sharp edges here. Look at these weights or coefficients. The top left numbers represent the broad, essential features of our block. But as we move toward the bottom right, the high-frequency details, the values become tiny, often nearly 0.
So these tiny numbers don't actually contribute much to the final look?
Since humans struggle to see fine spatial noise, we can aggressively zero these out. This is quantization. Most of our data is now gone, leaving only the essential recipe behind in the top left corner. Reconstructing the block shows it looks almost identical to the original. This trick shrinks a 3 megabyte file down to 100 kilobytes. That is the math inside every JPEG you have ever seen.